At 35,000 feet, the air outside an aircraft is thin, freezing, and unforgiving. Now imagine a sudden loss of cabin pressure, an event known as rapid decompression. In that moment, every device in the cockpit must survive, including something we pilots use every day, the electronic flight bag. But how do we make sure an EFB can handle such an extreme event? Today, we are taking you inside one of aviation's most intense qualification tests, the rapid decompression test. Rapid decompression is the sudden loss of cabin pressure, often modeled as a drop from cabin altitude, say 8,000 feet, to outside atmospheric pressure at 35,000 feet or above. And it happens in milliseconds. In aviation testing, we simulate this in a pressure chamber, recreating the exact conditions the cockpit, and the devices inside it, would face during a real emergency. Modern aircraft now rely heavily on electronic flight bags for charts, performance calculations, checklists, weather, and navigation planning. If an EFB shuts down or gets damaged during a decompression event, pilots could lose critical information exactly when they need it most. This is why aviation authorities require EFBs to pass environmental tests under standards like RTCA DO-160, including the rapid decompression test. So, what happens during the test? First, the EFB is placed inside a pressure chamber. The chamber simulates the aircraft cabin at 8,000 feet, around 10.92 psia. Once everything stabilizes, the real moment begins. The chamber pressure rapidly drops to match the outside air pressure at high altitude, often around 1.6 psia, equivalent to 51,000 feet. This decompression is performed in less than 1 second, replicating the violent pressure loss of a real-world event. After the pressure drop, the EFB is checked immediately. It must 1. Stay powered on. 2. Keep its display visible. 3. Maintain data integrity and 4. Avoid physical damage or screen cracking. If it fails any of these, the model cannot be approved for cockpit use. Rapid decompression events are rare, but aviation safety isn't based on luck. It's based on rigorous testing, worst-case scenarios, and ensuring that every device onboard performs when lives depend on it. Your EFB may look like a normal consumer tablet, but certified aviation units go through environmental stresses far beyond what everyday electronics ever see. So the next time you see a pilot tapping through flight plans or charts on an EFB, remember, that device survived pressures equal to the edge of space to earn its place in the cockpit. If you enjoyed this deep dive into aviation testing, hit that like button, subscribe for more aviation geek content, and drop a comment on what test or aircraft system you want to see next. Thanks for watching, and keep climbing.